Okay, now let's continue the shear and the moment, and we will calculate. We will calculate at the point D. At the point D, we will calculate at the point D. The shear and the moment at D. Okay, so it's easy. We need to calculate the first step. Calculate the reaction in the RB. So I think it's very easy for you to calculate. So I don't want to repeat here because this is very basic. So reflection A should be equal to 11 kips, and the reaction B should be equal to 9 kips. Okay, so this is about the reaction. So, and when we will calculate the shear moment at the D point, so we will draw the free body. This take free body of this partition, and in this partition we have some distribution load, and including one P concentrate load, and we have a reaction A. Here is 11 kips. Yeah, and totally this is 15 feet the distance. So actually this is according to the definition. According to the definition, we need to, everybody should know the definition. The definition of the positive is the shear should be this way. The moment is clockwise moment, and the D point here. D point should be here. D point. Okay, so according to the we have at the point D, the summation of the vertical force should be equal to 0. So we will calculate 11 minus 14, and the minus 0.2 is a uniform load. Is a keep foot, and you need to multiple 15 feet. Is and minus shear force is equal to 0. And I think it's better to write down in detail. So I would like to. Here is easy for your understanding. Is 11K and minus 14K kips. So from this equation, and you can calculate the shear is equal to minus 6 kips, and this is the first equilibrium equation. And the second is a summation moment at the D. Summation moment at the D should be equal to 0. So in this case, you can write down the formulation: minus 11k 15 feet. This is the arm, and the plus 14k and the multiple 6 feet the length, the arm, and the plus 0.2 kip per foot. This kip per foot is the quantity. And also you need to multiply the total length, 15 feet, and should be multiple the 7.5 feet. The idea is very clear because this is the center of the so the uniform load is another loading here. And we will is better to write them in another color. Should be, I think is better by this color. This is here. I would like to say this is this red color is with a equivalent equivalent concentrate load. Concentration load. So it's have an arm. It's a distance here. Is just the middle. So it's 7.5 feet. So this is the like the center. Body like waist center. Waist center is also we call this material center is here. So it's the half of 15 is equal to 7.5. So here so and the multiple moments equal to 0. So it's very easy to get the moment here is equal to 58.5 kip feet. So this is the answer. And it's a left hand side. So the first one is a left hand side. Left hand side. And the second, we need to calculate right hand side. When you calculate right hand side, it's look like this. Also take free body, and there is also we have a distribution load, and we also have this is the point D, and we also have the reaction of D. Yeah. So and according to the positive definition, but the positive of shear is look like this is upward, and the moment of the positive is clockwise. Okay, so similar with the summation our vertical force should be equal to 0. And in this case, we can get the equilibrium equation is the shear plus 9 kips is 9 kips is the RB, the deflection of the B, the 9 kips, and the plus 9 kip and the minus 0.2 kip per feet, and the multiple the distance 50 feet is equal to 0. So we can get, and in this case, we can get we can get the shear force. Shear force is equal to minus 6 kips. And also, and yeah, and the similar, we also have a equilibrium force here. So the arm should be half the arm is the distance the same, because the D is the midpoint. So distance is also to the D is also to 77.5 feet. Yeah. And the reflection B to here is the distance should be 9 from D. Distance should be 9 feet. So when we calculate my summation moment at the D point equal to 0, and we can very easy to write down minus moments and plus 9 kips and multiple the arm 9 feet and minus the 0.2 kip per feet and multiple the 15 feet. This is the length, and multiple to the arm 7.5 feet. Yeah, 7.5 feet is here. So after all the summation should be 0 equal to 0. Therefore, we can get we can get the moment is equal to 15.5 moments keep with. Yeah, in this case, it's very interesting. Very, very interesting. You look the shears here and the shear here. Yeah, the same. And also the moment is the same. So that means that's the idea is very clear. Is at the same point, the moment should be is the same. Is a couple. It's a couple at the point D and shear. Yeah, So the idea is very easy to understand. And in this is the point D, and we have the shear because it's a minus, so should be, if it is calculate the result is minus, so should be the shear that become like this. Is a 6 kip, and the moment is positive. So positive is like this. The moment is positive. So the moment is equal to 15.5. This is the moment. Yeah. So we will say the shear and the moment at the point D. At the point D is exist like a couple. So is a bending moment 15.8.5, and the shear is a couple is equal to 6K kips, and but the direction is minus, and the positive is here is a downward, but because after you calculate minus, so become this shear become upward here, and downward here. So this is our example for you.